Hello everyone, in this video let us solve this question. So we have 2 raised to power t is equal to t raised to power 32, and here we have to solve for the value of t. So t is the unknown we have to solve for. To solve this, solution, so we have 2 raised to power t is equal to t raised to power 32. Now, the first thing we're going to do is that we're going to eliminate power t from here. And to do so, we're going to multiply the equation with power 1 over t. So, this then becomes 2 raised to power t, all multiplied by power 1 over t is equal to, in bracket, t raised to power 32, all multiplied by power 1 over t. So with this, applying this rule that if you have a raised to power b or raised to power c, this equals a raised to power b times c. Applying this rule right here, what we then have is this, that we have 2 raised to power t times 1 is t over, we have t, which equals t, then power 32 times 1 is 32 over t. So with this, 2 raised to power t we divide t, we have 1 is equal to t raised to power 32 over t. And from here, 2 raised to power 1, the value is 2, which equals t raised to power 32 over t. Good. So with this, what we are then going to do is to eliminate power 32 from here. So, and to do so, simply multiply the equation with power 1 over 32, such that what we have is 2 raised to power 1 over 32 is equal to, in bracket, t raised to power 32 over t, then multiplied by 1 over 32, so as to eliminate 32 from here. Okay, good. With this, we have 2 raised to power 1 over 32, which equals t raised to power 32 times 1 is 32 over t times 32 is simply 32t. Okay, good. Such that what we have is this, that we have 2 raised to power 1 over 32, which equals t raised to power 32 we divide 32, what we have is 1 over t. Now, if you look at this equation closely, on the right hand side, the base right here is equal to the power denominator, but on the left hand side, the base right here is not equal to the power denominator. And in order for us to solve this further, we need to ensure that the base right here is also equal to the power denominator right here. Now, to do so, simply, we have 2 raised to power. We can factorize out 1 from this power. So we have 1 times 1 over 32, which equals t raised to power 1 over t. Now, if you do so, we're going to make use of a concept called equivalent fraction. Now, the concept is this. You see, 1 can be written as 2 over 2, because 2 divide 2, you have 1. It can be written as 3 over 3, as 4 over 4. Okay, now in this case, instead of writing down 1, we're going to replace this 1 right here with 2 over 2, such that what we then have is 2 raised to power. This one becomes 2 over 2. Then we have times 1 over 32 is equal to t raised to power 1 over t. So from here, we have 2 raised to power 2 times 1 is 2 over 2 times 32. The value is 64, which equals t raised to power 1 over t. So the next thing for us to do is to factorize out power 2 from here. So we have 2 raised to power 2 times 1 over 64, which equals t raised to power 1 over t. And with this, following this rule of indices, that if you have a raised to power b times c, this equals, in brackets, a raised to power b or raised to power c. Applying this rule right here, what we then have is this, that in brackets, 2 raised to power 2 or raised to power 1 over 64, which equals t raised to power 1 over t. So with this, 2 power of 2, the value is 4, raised to power 1 over 64, which equals t raised to power 1 over t. Now, at this junction, looking at this also, you will see that on the right-hand side, the base right here is equal to the power denominator, but on the left-hand side, the base right here is not still equal to the power denominator. And we need to ensure that the base here must equal the power denominator. So we are still going to simplify this further by making use of the real concept of equivalent fraction. But before then, let us factorize out 1 from here such that we have 4 raised to power 1 times 1 over 64, which equals t raised to power 1 over t. Now, making use of equivalent fraction concept, we can replace this 1. This one can be written as 2 over 2. So, what we have is 4 raised to power 2 over 2 times 1 over 64, which equals t raised to power 1 over t. And with this, okay, we have 4 raised to power 2 times 1 is 2 over 2 times 64 is 128, which equals t raised to power 1 over t. So from here, let us then factorize out power 2 from here. We have 4 raised to power 2 times 1 over 128, which equals t raised to power 1 over t. Such that if you apply this rule of indices, if you have a raised to power b times c, this equals in brackets a raised to power b all raised to power c. Applying this rule right here, what we have is this. We have in brackets 4 raised to power 2 all raised to power 1 over 128 is equal to t raised to power 1 over t. So from here, 4 squared is equal to 16 all raised to power 1 over 128, which equals t raised to power 1 over t. Now, at this junction, the base right here is equal to the power denominator, but the base right here is not still equal to the power denominator. So, we still need to simplify this further. And to do so, factorize out power 1 from here. What we have is 16 raised to power 1 times 1 over 128 is equal to t raised to power 1 over t. And we can then replace this power 1 right here as 1 can be written as 2 over 2, such that what we then have is this, that we have 16 raised to power 2 over 2 times 1 over 128 is equal to t raised to power 1 over t. Now from here, we have 16 raised to power 2 times 1 is 2 over 2 times 128 is 256, which equals t raised to power 1 over t. Such that with this, we can factorize out power 2 from here. This becomes 16 raised to power 2 times 1 over 256 is equal to t raised to power 1 over t. So applying this rule of indices, if you have a raised to power b times c, this equals in brackets a raised to power b all raised to power c. Applying this rule right here, what we have is in brackets 16 raised to power 2 all raised to power 1 over 256 is equal to t raised to power 1 over t. So with this, 16 squared, the value is equal to 256 raised to power 1 over 256, which equals t raised to power 1 over t. So looking at this, we have achieved our goal. The base right here is equal to the power denominator. Same thing also on the right hand side. The base right here is also equal to the power denominator. So we can then apply this rule that if you have a raised to power b, which equals a raised to power c, we can compare the exponents since the bases are equal, such that b is equal to c. Now, in this case, the bases are not equal, but the base and the power denominator are equal. So we can also compare the exponents, such that 1 over 256 is equal to 1 over t. So from here, simply multiply. T times 1 is t, which equals 256 times 1 is 256. And this is the value of t. But then let us confirm if actually this value of t is the correct solution. So let us check the question, which is 2 raised to power t which equals t raised to power 32. And we got the value of t as 256. So this becomes 2 raised to power 256 equals t is 256 raised to power 32. With this equal each other, question mark. So from here, we can express 256 as 256 can be written as 16 times 16. So this becomes 2 raised to power 16 times 16. With this equal 256, right, raised to power. We can express 32 as 2 times 16. So with this equal each other, question mark. So from here, following this rule of indices, that if you have a raised to power b times c, this equals in brackets a raised to power b all raised to power c. Applying this rule right here and here also, we then have in brackets 2 raised to power 16 all raised to power 16, which equals 256. So in bracket 256 all squared all raised to power 16. With this equal each other, question mark. So with this, 2 raised to power 16, the value is 65536 raised to power 16, which equals 256 squared is also 65536 all raised to power 16. Now, since they are equal to each other, this means that the value of t that we got as 256 is the correct solution for the given question. 2 raised to power t equals t raised to power 32. So with this, I hope you all enjoyed the video. Don't forget to like this video, subscribe to this channel. Thanks for watching. See you in the next video. Bye.